Alright, so 3.2 is all about system of equations, day 2. We're going to solve system of equations by substitution and elimination. Let's talk about substitution first. And here's a system. We're going to have y equals 2x plus 1. And we're going to have 2x plus y equals negative 7. Alright, so this is a system of equations. They're grouped together like this. And we're going to solve by substitution. Now, the trick to substitution is to get one of these variables by itself. And as it happens, y is by itself in the first equation. So, y is 2x plus 1. So what we're going to do is we're going to substitute that for y into the other equation. So this other equation is going to be 2x plus, but instead of y, we're going to substitute in 2x plus 1, because that's another value for y. Now, notice how I put parentheses around it. That's going to be important later. So for right now, I want you to write that. Oh yeah, by the way, equals negative 7. So the only thing that we did, we took the second equation. It's essentially the exact same. It's just that instead of y, we substituted in 2x plus 1. So now it's a solving problem with one variable. That's the whole point of solving this. So 2x plus 2x is 4x plus 2, excuse me, yikes. 4x plus 1 equals negative 7. Subtract 1 from both sides, you get 4x is negative 8. X is negative 2. X is negative 2. So, we found x, but that's only half the battle. Now we got to find y. Y, back from the beginning, y equals 2 times x, we found is negative 2, plus 1. So this is negative 4 plus 1, which is negative 3. So, our final answer, remember, if we were to graph these two lines, they would intersect at some point. And they intersect at the point negative 2, negative 3. That is our solution there. Alright, now, it's pretty simple to do substitution when a variable is already by itself, and we just see that we substitute it in. Let's do another example. We'll go with purple and green. 3x minus 2y equals 19. And we got x plus y equals 8. Now, substitution here, we need to get a variable by itself. So, you got to look for what is the easiest variable to get by itself. Now, the way I think of this is we get you want to get the variable by itself. You're the same way that you try and date people. You're looking for positive single people. You don't want some negative Nelly Eeyore person, and hopefully they're single. Otherwise, you got somebody chasing after you. So 3 is not positive nor single, or sorry, the top x term 3 is positive, but it's not single. This one is neither positive nor single, but the bottom, I have a positive single x and I have a positive single y. So both of these are viable candidates. All right. Now, let's have a little bit of vision. What I'd rather do is I'd rather get x by itself, so I would have to distribute the 3. So I'm going to get x by itself on this bottom one. Again, does it matter which one you get by itself? No. So x is equal to 8 minus y. Alright, but now I got a variable by itself, and I'm going to substitute that in to the top equation. So the top equation is going to become 3 times 8 minus y. Then you got minus 2y equals 19. This is why we put parentheses around the 8 minus y, is because it's 3 times the value of x. X is this whole thing, so we have to actually distribute this 3. So it's going to be 24 minus 3y minus 2y equals 19. Then combine like terms. You got 24 minus 5y equals 19. Subtract 24 from both sides. You got negative 5y equals negative 5. So y is positive 1. So we got our y value. But again, that's half the battle. Now we got to find x. X is 8 minus, 1. So x is 7. So again, this is an ordered pair. Our ordered pair is going to be the point 7, 1. Substitution. Write your answer as a ordered pair. All right, so now let's talk about elimination. I'm going to move on to page 2, though. Elimination. Now, your book calls it linear combination. They are the same thing. I was raised on elimination, so I'm going to roll with elimination. My first one, our first example here. 3m plus 5p equals 19. Let's go with, is there a better color? I'll go with green. M minus 2p is negative 1. Elimination. The whole point of elimination is to add these two equations up so that a variable eliminates. But as it is right now, a variable will not eliminate. So what we have to do is we have to multiply one of these by something such that the coefficients become the same except opposites. Coefficients are opposites. So here I got a 3 and a 1. I got to multiply one of these by something so that they'd have the same number. My choices are between the 3 and the 1 so that the m's eliminate, or the 5 and the 2 so that the p's eliminate. Now, if I go for p, I have to multiply so they have the same number. The lowest common factor of 5 and 2 is 10. All right, so I'd have to multiply the top by 2 and the bottom by 5. That's a lot of work. Instead, here I got 3 and 1 for m. I'm going to eliminate the m's by multiplying the bottom by not just 3. If I had 3, I would have positive 3. I'm going to multiply by negative 3. The top is going to stay the same. So this is going to be 3m plus 5p equals 19. And then we got negative 3m plus 2p. Oh, excuse me. Negative 3m plus 6p equals positive 3. So now these m's have the same coefficients but opposites. So when I add these up, they're going to cancel. And then we got 5p plus 6p is 11p equals 22. Thus our value for p is 2. All right, but now we still got to find m. What you do is go back to the beginning. Choose any one of these equations. Doesn't matter which, top one or bottom. I'm going to go with the bottom one because m minus 2 times p is 2 equals negative 1. Oh my goodness. So m equals 4. Oh my gosh, I'm sorry, y'all. M minus 4 equals negative 1. So m is 3. So we got our p value, we got our m value. We got both of these. So how do we write our answer? This is an xy, Smith. Here's the thing. If it's p and m, the way I want you to write it is in alphabetical order. So A, B, F, G, H, I, J, K, L, M, N, O, P. So m comes first, then comes p. Alphabetical order. My answer is 3, 2. All right, so elimination, that should be review. Let's try one more. This one I'm going to do in straight up black. 3x plus 7y equals 6. 2x plus 9y equals 4. Go ahead and give this one a shot yourself. Go ahead and pause it and then check your answer. so hopefully you gave that a shot. In this case, again, I'm going to eliminate the x's, the first term. So 3 and 2, I need a 6. However, one's going to be positive, one's going to be negative. 2 is going to be 6x plus 14y equals 12. And the bottom, I'm going to multiply by negative 3. That gives me negative 6x minus 27y equals negative 12. All right, so when I add these up, these cancel. I get, oh snap, what is that, 13? Negative 13y equals, that mess is 0. So divide by negative 13, y equals, what is 0 divided by negative 13? It is 0. So my y term is 0. I'm going to go and choose, which one I want to mess with? I'm going to mess with it with the bottom one. So I got 2x plus 9 times 0 equals 4. That's times. So you got 2x, 9 times 0 is 0. 2x plus 0 is 2x. 2x is equal to 4. X is 2. So hopefully your final answer was the 0.2, 0. All right, so substitution and elimination. Here's the thing. In this problem here, now you can see substitution would be a bad choice right from the start because there's no positive single people. Right? Everything's positive, but nobody's single. Substitution is a bad choice. I would go with elimination. However, back at the beginning, this one, I could go with elimination. However, did you notice how everything was stacked? X's on top of X's, Y's on top of Y's when we did elimination. Here, they're not. This one's kind of ready-made for substitution. So sometimes substitution is better, sometimes elimination is better. Just practice will help you get better and figure out when to do which process. So that's the lesson about substitution and elimination. Good day. Y'all don't know nothing about no Paul Harvey.